Hello everybody, welcome to the YouTube channel of Department of Physics VBSPU. I hope you all are doing well. So today we are going to perform an experiment of electronics that is called anacom. So anacom is a combination of two words, that is analog and computer. So an analog computer is a device that processes information using continuous changeable physical quantities such as electrical voltage or mechanical motion to model a problem. Unlike digital computer that use discrete on and off values or 0 or 1 values, analog computer uses physical phenomena that directly represent the mathematical variable of the system being modeled. It offers nearly instantaneous result for certain complex simulation. It includes amplifier, integrator, and multipliers to perform summation, integration, and to model the system. So we can say that when there were no computers like to write the code, there were analog computer to model the system. So now we will talk about system description. So here uh, we are using the modular analog computer DP10. It is a educational analog computing system designed to simulate mathematical operation using electrical voltage. So let me show it to you properly. So if we talk about system description, so here are 10 knobs, and these 10 knobs are for the coefficient potentiometer. As you can see that from here to here there are 10 coefficient potentiometer. So these 10 knobs are for this. We can change the value with the help of these knobs. Here is our meter scale reading, and here is our range button, here is our mode button, and here is our function switch, and here are another 10 knobs, and these 10 knobs are divided into two parts. These 5 knobs are for summer amplifier. This is summer amplifier, here is plus sign, so this is summer amplifier. And yeah, these are 5 in counts, and these fives are for integrator amplifier. So here are like our integrator, these are also 5. Here is our jumper switches, and yeah, here is our null button. When we will uh, use page cord to attach this, so the output of yeah, we will add our output here, so it will like tell us the value, what voltage we are having. So here is the important key is that how you will like read this. So as you can see that here is 2 volt, here is 10 volt, and here is 20 volt. So when you have to measure 2 volt, you just have to assume that there is no zero. Like yeah, there is 2, there is 1, there is 0, there is 1, there is 2. So yeah, when you measure this in 2 volt, you will assume this. And when you measure it in 10 volt, and the fact is that when you measure it in 2 volt, just put this button, like press this button to 2 volt, like it is on 20 volt now. So it is like it will measure the value from minus 20 to plus 20. So yeah, if you have to measure 10 volt, then here you will measure from here to here, and if you will measure 20 volt from here to here. So yeah, this was the system description. Now we will talk about like what operation can we perform with this anacom computer, like analog computer. So like we can perform many operations. We can like solve the first order linear differential equation, second order linear differential equation, or we can solve simultaneous equation of 2 and 3 variable using analog computer. So we will start with simultaneous equation and of 2 and 3 variable using analog computer. So now before jumping on our operator, we have to do some mathematical calculation. So to do that, so what we are going to do, we are going to solve simultaneous equation of 2 and 3 variable. So let me take 2 variable equation. So here I am taking x plus y equal to 8, and yeah, this is my equation 1, and here x minus x plus y equal to 4, this is my equation 2. So if we will solve this mathematically, then we will get like 2y equal to 12, y equal to 6, and x equal to, okay. So this was mathematical term. Now you will see in the end that when I will perform the experiment, we will get like, yeah, almost this value of y and this value of x from the analog computer. But we can't put this value directly to analog computer, like we have to make some changes there. So let me write it again: x plus y equal to 8 and minus x plus y equal to 4. So now what I will do is like to make this equation in term of x. So yeah, x equal to uh, 8 minus y. And now what I have to do is that now I have the value of x. So I have to make it like this. I have to make the value of y like this, so that this x will be useful for this. So what I can do, I can do y, wait, let me first write this. We have minus x plus y equal to 4. So what I can do, I can do minus x uh, minus 4 equal to minus y. So yeah, now I am ready to perform this. I have got my x value, I have got my minus y value. So yeah, now okay, let me show you one more thing here. Okay, so how I am going to perform this in my analog computer, I am going to represent that here. So yeah, let us assume this is my input, and this is my summer amplifier. I already like yeah, mentioned that earlier. So now I have gotten my x equal to 8 minus y. So I am giving it minus y voltage here and plus 8 volt here. So what I will get, I will get x. But when it goes through this process, the sign of x changes to minus x. Okay, so from this I got minus x. Now what is going to happen, I am going to add this output to another summer amplifier input. So I have gotten minus x. So can you see that from here that minus x is already presented there? Okay, so what I have to do, I only have to apply minus 4 volt. If I apply minus 4 volt, then what I am getting, I am getting minus x minus y minus 4 equal to, it's 4. Don't think that it is y, it's 4. So yeah, I am going to get minus y, right? So I am going to get the value minus y. So now what I will do, okay, so here is another term arises. So can you guess what term arises? I got minus y. Okay, but as I mentioned you earlier, when this goes through this, it turns this sign into plus. But I have here minus, I have here plus, so I can't like connect it directly. Now what I have to do, I have to add another circuit. Like yeah, I have to like add it to another summer amplifier. Now yeah, this will go through this, and now when this y will goes through this summer amplifier, it will turn it into minus y. So here minus y is going to connect with this. So yeah, this was like the thing that I am going to perform there. Okay, so let's see it on analog computer. So now we are going to do these things on our analog computer, and you will see that we are going to get the same result, almost the same result that we got here. So what we have to do, we have to on our analog computer, which I already did. Like when you have to perform this experiment, you should like on it for 15 minutes so that it warms up, so it give a good result. So what like what operator I need to perform this? I already have analog computer, I need patch cord, and yeah, here is a multimeter. I will show you how to read multimeter in another video, but let make this video specific to our analog computer. So here are our patch cord, which we will add it here. And there is one question arises in your mind that here is already meter voltage reading. Yeah, there is already this meter to read the voltage, so why we are using multimeter? Actually it measure the voltage with more precision, so yeah, we have it. So we will check the values with these two. Okay, so whenever we perform any experiment, what we do first, we do calibration, like we calibrate our system so that there we assure ourselves that there is no error. So how we will calibrate summer amplifier? Okay, so to calibrate summer amplifier, what I have to do, I have to take some patch cord. Okay, so what I have to do, I have to add, actually let me mention you this, that this amplifier, this one, like this one summer amplifier is not working properly, so I am not going to use this. I will start it from here. So what I have to do, I have to add this patch cord to ground, and I have to add this here. And what I have to do next is that I have to add my one patch cord here on the output, and another is here. Okay, so actually what is happening here, you are seeing that it is on 0, so I already calibrated it. So what happened, like if it was not calibrated, so let me show you this. If it was not calibrated, the value will like you will find the value from like anywhere. So what you have to do, you have to do, okay, so I am using the second amplifier, second summer amplifier. So whatever changes I have to do, I have to do with this button. Like this one is for the first amplifier and this one is for the second amplifier. So yeah, I will do everything with this. If I will add anything on third, I will like change the value with the third one. So yeah, as you can see that now that is not calibrated. So what I have to do, I have to calibrate it. How can I calibrate it? I will make it to 0. Okay, so yeah, okay, so now it is on 0, so we can say that this is calibrated. Okay, now let me remove this. I hope you understand how to calibrate this. Actually you can see this on multimeter too, but I will show you the final result on multimeter. Okay, now move on to our object. So as you can see that here, these were the mathematical operation, and now you can see that here x equal to 8 minus y. So what I have to do, I have to give like minus y volt, minus 8 sorry, plus 8 volt. Here is like, you can see that, yeah, it positive, and this one is negative, but I don't know the value of this. So okay, let's see. Let me first, this one is 4 minus y, I don't know the value of minus y, so leave this here. Okay, we will find the value of minus y in the end. Now what I have to do, I have to give it 8 volt. So how can I give it 8 volt? Okay, so what I have to do, I have to, this is positive reference and this is negative reference. So here the value is positive 10 volt and here the value is negative 10 volt. Actually it is already presented in the system. I do not have to do anything with this. So what I will do, I will add, I want positive voltage, so I will add this here and this here. And now what I am going to do, I will add this. I think I should use a small patch cord. Yeah, it will work. So yeah, I added this here, and now this here. So what I am going to do now, I am going to set it to 8 volt. I already told you how to measure this, so it is already on 20 volts. So now you know that it will goes like 1 2 3 4 5 6 7 8. So okay, so now I have to change the voltage here. So what I am going to do, I can change it from here. So it's on first reference point, so I will do that with first reference, like yeah, this first knob. So I am going to make it to 8. Okay, 1 2 3 4 5 6 7 and 8. Okay, so I got 8 volts. Now what I am going to do, I am going to remove this from here and add this here. Okay, so our first equation, yeah, our first equation is ready. Now what I have to do, I have to do the second equation. So I told you that when it passes through this, it will become minus x. So it will become minus x. So I already yeah, I only have to add minus 4 volt. How can I add minus 4 volt? So now I want minus value. I will do the same thing. I am going to do the same thing but with the negative one. Okay, so as you can see that I added this minus, I added this patch cord to the minus, and here to this, and here to this, and now on the meter reading. Okay, so now I have to set it to what? I have to set it to minus 4. So it was on second coefficient potentiometer, so I have to use second coefficient potentiometer. And okay, now we will change the value. 1 2 3 and 4. Okay, we got it. So now I got minus 4 volt, as you can see that minus 4 volt. So I am going to add it here on my second summer amplifier, and I have to add the output of the first amplifier to here. I got here minus x, and I got here minus 4 volt. So yeah, minus 4 volt, minus 4 volt minus x. As you can see that here, minus x minus 4 equal to minus y. So what we are going to get here, we are going to get here minus y. Okay, we already have here minus y, we are going to get here minus y. But here is another thing arises, and that is this summer amplifier. When this will go through this, it will turn minus y to plus y. So now what we have to do, we have to add minus y value to another amplifier, so that it will become, yeah, so yeah, it is here minus y, it will become plus y. So what I have to do, I have to add this to another amplifier, so that the value of plus y become minus y, so that I can complete my circuit. Okay, so what I am going to do, I am going to add it, yeah, this patch cord here. So I am going to add the output to another summer amplifier input. Now I can, yeah, add this final. Okay, so now our system is ready. Now whatever I have did this here is here. So now whatever I have got here is going to be present here. So now, as I told you that I will show you the end result in the multimeter. So let's hope the result will be satisfactory. Okay, now what I have to do, I have to add this to the ground. Okay, I added this to the ground, and now what I have to do, I have to measure it, like measure the value of minus y from here. Okay, so before I do this, let's see the value of y. So the value of y equal to 6. So what I want here is like almost 6. Okay, so let's see this. Oh, uh, there is no meaning of losing this. I can measure the value from here too. Okay, so see, here I am getting 6.58. Okay, and here it's 6. So yeah, it's almost 6. And now let's see the value of x. Okay, so from where I can like measure the value of x, I can do that from here and here. Okay, let's do it from here. Okay, so let me show you. Okay, we are getting 2.002. So we can say that yeah, like our experimental value and our our mathematical values is almost same. So what we are getting from experimental, we are getting y equal to 6.58, yeah, almost, and x equal to like 2.002. So yeah, so we can say that here we are getting this value and here we are getting this value, so it's like almost the same value. So here we completed our experiment, and in this experiment we have discussed about how can we solve equations for two variables in analog computer. And in upcoming videos we will talk about how can we solve a little bit complex two variable equation and three variable equation in analog computer. So that was for today, and I hope you understand it all how this thing happened. And yeah, that's it. Thank you for watching.